going to take you through the Ranger hull and deck laminating process here in just a moment. And at the very heart of this process is a philosophy that Forrest Wood started from the very beginning. And that philosophy was that we don't ever rest on our laurels. There's lots of materials, composites and special materials that you hear talk about perhaps. And I want to show you some of the differences as it relates to the Ranger hull and what we're putting into that hull. At the very backbone of the Ranger construction is pultrusion. And this is a process, really, where we are pulling this fiberglass through a heated die to make a constant cross-section, whatever shape that we want. And this thing has some really good attributes, and one of those is, and which is very important in boat building, is screw retention, which we know that while the hardware that's screwed on our boat, we have to have the proper backing, or those screws won't stay tight. Let me show you in some of the widely used materials that's on the market that we incidentally don't use. Let me show you how a screw goes into that material. This is without a pilot hole, by the way, so I'm going right into the material, and as you can see, there's no bottom. That screw's actually spinning in the composite because it just don't have the integrity to hold the screw. On the other hand, take that same screw and run it into a piece of our pull-treated material, which is not as thick as that material, but the thickness is really not what we're looking at. We're looking at the structural integrity of the composite itself. Let's run a screw into the pull-treated material, and you can see the bits is spinning in the screw. So the screw it'd be next to impossible to strip that screw. I'll see if I can get it out if I haven't ruined the head. But it's actually formed threads inside that composite. The reason that is like that is no accident. This material has been engineered to be that way. And as you can see, the thickness of the material, the pull-treated material, is made up of multiple layers of fiberglass. And we actually pull that through a heated die. This is the material going in the backside of the die, and this is the material coming out. And then we cut it to shape with a water jet cutter and use it in a lot of places in a Ranger boat. We build this here at Ranger Factory, so it's an exclusive material just for Ranger boats. We started out with it in the transom many years ago, and now we've integrated into many, many places in the boat. We'll see on the deck area that it's used for reinforcement for places like under your seat base, where you're sitting fishing all day, behind the hinges, behind the screws that fasten the lids to the boat. Some of the materials that go into the lamination of the hull are a woven roving material, which is fiberglass that have been woven into whatever pattern that's proper for that particular application. In other words, if we want more of the strength to go in the longitudinal direction, we'll use fibers that have more material running in that direction. If we don't need it in the transverse direction, then obviously we'll leave out some of that material and put it in this direction. And what this does is gives you multiple layers, and this is just a simple way of showing those various layers that go on next to the gel coat to build up that laminate and create the Ranger hull. One of the other things that we do that we think is really important is the material that we put in the strakes, or the longitudinal portions of the boat, along with the stringers. This material is a roving material, which means all the strength is just running in the one direction, which we're wanting to get stiffness in the bottom of the hull. So we've added this material. It goes in wet. This is just for illustrative purposes to show you how much strength we're actually adding to that chime by adding that material. And some of the more commonly used materials are a putty, and you can see that this is just a thin layer, probably about 3/16 to 1/4 of an inch, that we've laminated out of some similar materials. And this is used in the strakes on many boats, and you can see that the longitudinal stiffness just isn't there. And so if you were comparing the two products, the material that we put in our strakes and the material that's commonly used in many other boat applications, you can see by comparison that there is no comparison. Let me show you. This is actually our transom, and it's a unitized structure. This is built out of a series of pull-treated components and glued together with a methacrylate glue so that they're virtually one piece. This piece then is put into the boat. So actually, we're going to build that Ranger. Once we get this hull laminated, like I spoke about earlier, once we get the hull laminated, this piece is going to go in the very next thing. So the rest of the hull is going to be built around this transom. As opposed to building a boat and sticking a transom in it, this is the heart of the Ranger. Here's a couple of areas where Ranger's really led the pack. We've been using fiberglass stringers for over 20 years. These stringers are all fiberglass. They go from the stern to the bow. They're foam filled, fiberglass into the hull, so they become, it's really a monolithic structure, if you will. Once we put these stringers in, we fiberglass over them and around them, and we fill the core with foam as well as the side areas with foam. This pull-treated transom, I showed you the unit a little bit ago. This has been fiberglass inside the hull, so now it becomes a very important structural member of the boat. The outboard motor will actually be bolted through in this area. So you can see all of the stresses that the outboard motor is going to subject to this transom are not just going to be concentrated in this one area, but pushed forward throughout the hull, even to the stringer. These go all the way down to the bottom of the hull and are tied in fiberglass all around the shape of the hull. So this is a very integral part of the hull now. And now that we're in the actual hull, although it's still inside the mold, I could show you some of the things we learned even from finite element analysis, where the stresses were. It seems that if we strengthen the transom or the floor or whatever portion of the boat, it can divert or push those stresses in different areas. So we've learned through finite element analysis, we kind of push it right on out of the hull. Other areas that we've learned to use the fiberglass, pull-treated fiberglass technology is in areas of the floor, which would, this area, particular area in this model, is under the fuel tanks. And this is hadn't been put in place, but just to give you an idea, a very lightweight material, but yet very, very strong and very stiff. This pretty much exemplifies what we call zone tempering, which in effect is putting the right components at the right place in that hull. The transom takes on a different character than perhaps the stringers of the floor. They need to be built out of different materials, and that's why we use such a diverse offering of materials, because they're placed in the right place, strategically placed, engineered to be the strongest that they possibly can be for that given area. Well, we've examined the details of building a Ranger hull, and I think you'll agree with me that there's a lot goes into that production. Now, in similar manner, we're going to look at the deck side of things and see what it takes to build that upper half of the boat that we call the deck. We're now looking at a deck, and it's in its mold, turned upside down, obviously. The initial layers of fiberglass have been applied here. What we've done is put a skin coat over the entire gel-coated surface, much like we saw happen over on the hull side. What's happening now is that we're starting to build up these layers and put in backing where it's needed. For example, we put the pull-treated material in all these various areas and behind where screws will be located. We'll also put the pull-treated material in, for example, where the seat base is. Well, we looked at again over in hulls, and we saw that details really make the difference, and that's exactly what we're looking at here on the deck side right now. Details do make the difference. You know, they say that beauty is only skin deep, but I'll tell you that quality on the Ranger side comes from the inside out. And inside, underneath these decks where you normally wouldn't have the opportunity to look, I want to show you some things that are happening underneath there as we build up this laminate that really will give you the assurance that this is the best it can be. For example, we've taken parts like the rod box end divider, which in order to have a no wood construction, we've found substitute materials over the years. This is lightweight, very strong. It's an exclusive technology that we developed for the transoms, but it works real well in a lot of the other areas of the boat. Its screw retention properties are excellent, and you'll find that in many, many places. This lightweight material that has been pull-treated through that die, we engineer it exactly the way we want it for the application to which we're using it in. In this case, we want good screw retention. These are located throughout the areas of the deck, so that if there's a piece of hardware, for example, a hinge, on the back side of that, you'll know that those screws are going into a material that has excellent screw retention properties. We have a dry lip that we actually mold into the decks. Every storage box that we want to remain dry, we put a lip on it and a seal On the back side, some things are happening on this laminate to ensure that that's that way each time. Another real critical point is on the back of the seat bases. When you're sitting on that front deck in that casting seat, you want the assurance to know that there's something underneath that. We've built a great foundation, again, using the pull-treated material. It's no rot, it doesn't deteriorate with time, and it's encapsulated between the fiberglass. Another material that we use in many places is structural urethane, which is a real high-density material. Again, it's lightweight. When encapsulated with fiberglass, it makes an excellent stiffener for areas such as the decks that we're looking at. One of the things that needs to be mentioned is that there's a core material that's sprayed on in strategic locations on the neutral axis. What this does for us is gives us the stiffness that we need without adding a lot of weight. So we're putting this core material between the inner and outer layers of fiberglass, which gives us some tremendous stiffness, and that's very important on these deck areas. Let me summarize now the deck construction. After the gel coat is complete on the deck, we're going to start adding or building up this laminate. The skin coat is applied first and allowed to dry. This is to build a barrier between that gel coat finish and the rest of the laminate. As we go further into the laminating process, we start adding components like pultrusion, backup parts that will be sandwiched or encapsulated inside the laminate. We'll spray on a core material in the middle of this laminate to ensure that we have the proper stiffness that we need. We're also adding various stiffening components to this process as we go along. We've looked at the deck lamination structure, how this has come together, but we're not there yet. We need to go over and look at the assembly process and understand how, as we add these boxes and storages and these other key components, how it's stiffening this and giving us that one-piece feel. We're inside our closed cavity bag molding department, which we call CCBM. And what we do here is build a multitude of hatches, lids, covers, live wells. Just about every storage box and live well is built here in this department. That's as important because they're built out of fiberglass, the same material that we build the boat hulls and the boat decks from, as opposed to a lot of other manufacturers that might use a plastic or a rotomolded or even a vacuum form part that wouldn't have the durability. But the Ranger boats are built the same way inside the boxes and the lids as they are the hulls and the decks. And I'll show you a little bit about why that's important. I have here a core that is part of a lid. This will actually be a rod storage lid. And you can see that this fiberglass is already loaded with a core of Pledgicel material. Now, this is a rigid foam material that will act as the core of the lid. Also, that we can, because we're doing this with a vacuum bagging process, we can be consistent and build these lids identical one to another. You can see that we can also add things in the mold, like this strip of aluminum is added, and this will be the backer for the hinge when we include it, when we attach it to the boat. This hinge point will be here. Also, we use a pull-treated material, the same material that our transom is made out of, and we can load this into the lid. So it gives a very, very rigid material that will hold screws, for such as the shock that holds the lid up, again, the hinges or the locks or latches. So we can build these consistently and effectively, and the repeatability of this process is second to none. So we can load the pull-treated material in, we can do the aluminum, we can change the laminate structure. Once we decide what core material we want to use, every lid will be that way. One of the important things of using the Pledgicel foam and the fiberglass is because the thermal barrier qualities that glass has along with the foam core. What we've found that, as opposed to a lot of the aluminum lids that are used on competitive products, we see a 20%, upwards to 20% reduction in heat from the ambient temperature outside, for example, to the inside of the live well. Now that's important if you're fishing in a hot summertime and you're trying to keep those live wells as cool as possible. Another thing, that the advantage it gives you is when you have these kind of lids over rod boxes, it reduces the condensation. And also on the storage boxes that are doubling as coolers, it makes a tremendous difference in the ability for that to hold ice. So this process is one that's unique to us and that we're very proud of. It's called CCBM, closed cavity bag molding. It's a vacuum assisted process that allows us repeatability day after day after day.